Hey Stats fans, it's time for video number 40, Interpreting Slope. Mr. Lewis is off today, so it's just me and you. We want to do two examples, and we'll hit the journal assignment. So our first example, we're going to use some data that we've used in class. The explanatory variable are absences from class, the number of absences, and the response variable is the final grade of the students. And as we see, it's a negative association. The more absences, the lower the final grade tends to be. We want to start interpreting slope, understanding what slope is telling us a little bit more. In the equation, we know that slope is the coefficient or the number multiplying the x variable. So the slope in this problem is negative 2.83. But we want to be able to give the units for slope and explain what it's telling us. So we're going to complete a table to kind of do that for us. When I put x equals 0 into the equation, I get 88.7 minus 2.83 times 0, which is just 88.7. Okay, when I put in 1, I get 88.7 minus 2.83, which is 85.87. If I keep going, if I put in 2 for x, I get 88.7 minus 2.83 times 2. I get 83.04. And if I put in 3, I get 80.21. And if I put in x equals 4, I get 77.38. That's kind of enough to make my point. It's kind of hard to see because of the decimals, but because this is a linear pattern, equation for a line, if x changes by 1, the y values change by the slope. These are actually going down by 2.83 every time. So to go from 88.7 to 85.87 was a drop of 2.83. And same thing from here to here. That was minus 2.83. And from here to here, same thing, minus 2.83, etc. So that helps us understand what slope is telling us. Every time x goes up by 1, or every time the number of absences goes up by 1, because that's what x was, the final grades go down by 2.83, at least on our line. Okay, so every time x goes up by 1, every time we go over 1, it turns out y is going down by 2.83. So this is a rate of change. Now, we got to distinguish. This is how fast our line is changing. The data actually varies about the line. It's not changing at a constant rate. We're talking about the rate of change of the line of best fit, which approximates the data. Okay, so here we go. Find the slope, and what are the units? So as we said, the slope is negative 2.83. To find the units, we got to remember that slope is the change in y over the change in x. In fact, from algebra, you remember that slope is y2 minus y1, should be a y, divided by x2 minus x1. The change in y coordinates divided by the change in the x coordinates. So the units for slope are the units for y divided by the units for x. This time the units for y are percentage points. So I'm going to put percentage points. I'm going to abbreviate a little bit, over the units for x, which are absences. Okay, so it turns out that this is the rate of change. On average, the percentage points decrease by 2.83 for every absence. Okay, and that's the basis of interpreting the slope. There's something important we have to say here. Whenever we explain what the slope means, we need the words on average. Because the data values, as I said, aren't really changing at a steady rate. They kind of fluctuate about the line. It's the line of best fit we're talking about that's decreasing 2.83 for every change in x. So on average, for every additional absence, the final grade decreases by 2.83. Takes me so long to write this. Okay, so there are a couple key things here. One, I said on average. That's because the line kind of averages this out. For each additional absence, okay, so that's every time the x-coordinate goes up by 1, what happens? The y-coordinate decreases by 2.83. We don't want to talk about the x and y. We don't want to refer to them as x and y. We want to refer to what they are. So for every additional absence, final grade decreases by 2.83. Okay, so we got to say it in context. Okay, here we go. Our second example. This too is some familiar data. This is the grams of fat in some hamburgers and the number of calories in the hamburgers. We've seen this data before. And here's the line of best fit is drawn. Here's the equation for the line of best fit, which we got at another time. And we want to use it to complete the table. Again, we're kind of trying to understand the slope here, 11.06, is telling me the rate of change. Okay, so when x is 19, if I put 19 in for fat grams, this time instead of x and y, I wrote it another way you'd see the equation, with the names of the variables. So when the fat is 19, I stick it in here, multiply by 11.06, add 210.95, I get 421.09. That's how many calories are predicted to be in that hamburger. In a hamburger that has 20 grams of fat, we would predict 432.15 calories, and 21 grams would be 443.21. If a hamburger has 22 grams, we have 454.27, and we see our predictions increasing by the slope each time. I'll put one more down, and that's kind of enough. 465.33. These are all predicted values. And as I said, what are they changing by? Well, every time the number of fat grams goes up by 1, this is increasing by 11.06. And from here to here, what's the change? 11.06. And from here to here, 11.06. So hopefully you get the idea. I can see it when I just make a table of predicted values. How much it changes by is the slope. Okay, so find the slope, 11.06. But you have to give the units. So the units are the y variables over the y units over the x units. So in this case, this would be calories per grams. Or if you want, you could say grams of fat. So it turns out for each additional gram of fat, you get 11.06 more calories on average. Okay, so on average, for each additional gram of fat, so that's every time the x-coordinate goes up by 1, so that would be an additional gram of fat. The hamburgers have, or we could say there are 11.06 more calories. Or we could have said that the calories increased by 11.06. Okay, so that's interpreting the slope. I got my on average. Because it's the line of best fit we're talking about. It's the rate increase of the line, which models the data. So it kind of averages for the data. On average, for each additional gram of fat, there are 11.06 more calories. Okay, so we've learned that the units for slope are the y units over the x units. Sometimes that can get a little crazy, but you just got to remember y over x, whatever they are. Then interpret the slope. You got to include the on average part. That's important. You'll get knocked off points if you don't include that. Then for each additional, for every time x goes up by 1, whatever that variable is, the y variable is changing by the slope. Okay, so I want you to give this a try on your own. Here's some data we've also used in class. We're recycling data. We're trying to save data, I guess. So this is the data from the used Cherokees. Remember, the explanatory variable is the age in years, and the response variable is the price in dollars. So we're going to find the line of best fit. I think we've already done that, but you can find it again. For part B, find the slope and record the units also. What would be the units for the slope? Finding the units actually helps you interpret it. If you understand what the units are, then the very next step is to interpret. So go ahead and explain, and don't forget the words on average. All right, good luck. We'll check your journals in class.